To find areas under the standard normal curve, so remember standard normal curve is our z distribution or our z curve. Basically what you want to do first is you want to sketch the standard normal curve and shade the appropriate area that you're trying to find on the curve. The second step is you want to find the area following the directions for 3 separate cases. There are only 3. So if you're finding area to the left, remember this is the value that your z-score table is going to give you. So you just literally look up that z-score in the table, and that is your area, or that is your probability. So area to the left of z equaling 1.23, for example, in this case, based on our table, so sketching it, so we would sketch a z distribution, 1.23. Since it's positive, it's going to be to the right of 0, a little bit to the right of the inflection point. And we want area to the left, so we shade the left-hand side of that. It's shaded in blue on this picture. Look, all we have to do for this one is look that value up directly on the table. So we just look up 1.23, and we get the 0.8907. So if we want area to the right of a z value, we have to find the normal area that corresponds to z. But then because we want area to the right, we have to subtract from 1. Because area to the right, remember area to the right is the probability z is greater than or equal to some value. And what our table is giving us is area to the left, which is less than or equal to. So remember, this is the complement. So the reason we're subtracting from 1 is because it's the complement of what we have on the table. It's the complement of the probability z is less than or equal to some value z. So say, for example, we want to find the area to the right of 1.23. Then we still sketch our z distribution, draw our 1.23 where it is, shade in on the right-hand side. But when we look it up on the table, we get 0.8907. So we want area to the right. So because it's the complement of it, so right is the complement of left, is another way of thinking about it. We just subtract from 1 because we're dealing with a complement to get our probability. So the area to the right of 1.23 is 0.1093. So to find the area between two z-scores, what you do is you find the area corresponding to each z-score in the standard normal table, and then subtract the smaller area from the larger area. So basically what we're doing is you find the large area, so z equaling 1.23. What you're doing is you're finding the entire area to the left of that value. But then we just subtract off the piece we don't want. So whatever our smaller z value is, we're basically saying, okay, we're just going to subtract the area to the left of that because we don't care about it. We only want what's in between the two z-scores. So let's say I want to find the area between z equaling 1.23 and z equaling negative 0.75. So this is another way of saying the probability that z is between negative 0.75 and 1.23. And so the way we would do that, we would look up the 1.23 on our table, get the area to the left of that, which in this case is 0.8907, and then subtract off our area to the right, or sorry, area to the left of negative 0.75, which is 0.2266, and that difference, in this case 0.6641, is our area between the two, or the probability that z is between those two z values. So let's look at an example. So let's find the area under the standard normal curve to the left of z equaling negative 0.99. So to do that, our first step, sketch the z distribution, see what it looks like. So here, z distribution is just a normal distribution. Negative 0.99 is almost negative 1. So right around your inflection point is where that z value should be. So label it. So z equals negative 0.99. And we want area to the left, so shade in on the left-hand side. So because we are looking for area to a left, remember this is the one you can just look up on the table. So if we look up this on our table, when you look it up, you should get the area to the left being 0.1611. And so what we're really saying this is the probability that z is less than or equal to negative 0.99. So the probability z is less than or equal to negative 0.99 is 0.1611. So remember, to get that, you just go on table A, so the negative side of the z values, go down the first column to negative 0.9, and go across the top to 0.09. All right, similarly, let's find area under the normal curve to the right of z equaling 1.06. So same idea, first step, sketch it out. So draw our normal distribution. And so z equaling 1.06 is on the positive side, so it's on the right-hand side of the mean. And it's pretty close again to our inflection point. So same idea, sketching on the right-hand side in this case because that's what we want. So what we're finding, this is the probability z is greater than or equal to 1.06. But then it's going to be 1 minus the value on our z-score table. So in this case, on our z-score table, we get a value of an area of 0.8554. And so to find the area to the right, we have to subtract that from 1. And so when we do that, we end up getting an area equal to 0.1446. Lastly, let's find the area under the standard normal curve between z equaling negative 1.5 and z equaling 1.25. So same idea, so sketch our normal distribution. So negative 1.5 somewhere about here, and 1.25 somewhere about there. And we want the area in between the two. So this area in the middle. So to do that, so probability z is between negative 1.5 and 1.25. We just look up 1.25 on the table. We get an area of 0.8944. And subtract off the area to the left of negative 1.50. So we look up negative 1.50 on our z-score table, and we get 0.0668. And that's what we're going to subtract. And so when we do that, we end up getting an area of 0.8276.